Okay, this is example 2.11. A stone is thrown upward and it reaches its highest point 2.2 seconds later. How high did it go? What was its initial speed? So in this particular problem, we're throwing a stone up. And what they tell us is that it went up it went to its highest point. So right here, that's the highest point. 2.2 seconds. How far was it? Okay. So the way we would do that is actually first consider that if it went up to if it went up to some highest value, some height, so we'll call that h. The amount of time it takes to go up is actually the same as the amount of time to come back down. And we can calculate how long it takes to go down very easily. That's freefall. H is equal to 1/2 gt squared. So if it takes 2.2 seconds for it to fall all the way back down to the earth, to the ground, then we can calculate what that height is, and that would be the same height as you threw it up to, right? So what happens is when you throw something up, it takes 2.2 seconds to get up, and then it takes 2.2 seconds to come down. And the final velocity right before it hits the ground is equal to the velocity that you threw it up with. So it goes up fast, slower, 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 till the velocity stops. And then it goes faster, 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 until it finally reaches a final velocity that was essentially the same speed as when you threw it up. Okay, so let's find that height. H is equal to 1/2 gt squared. So that's 1/2 times 9.8 meters per second squared, and that's 2.2 seconds quantity squared. Okay, so let's see what that is. We could approximate it as 2 seconds, but it's a little bit off of 2 seconds. It's 2.2. Okay, so 1/2 0.5 times 9.8 times 2.2, and we're going to square that. And it looks like it comes out to about 23.7 meters. 23.7 meters looks like our time there. Okay, we see why it's meters, right? Because the second squared cancels with the second squared and you just got meters. So in other words, this height all the way to the top was 23.7 meters. Okay, now, as I also said, when it hits the ground, it'll be moving at the same speed downward as when you threw it up as it went up. So it starts off real fast, slows down till it gets to the pinnacle, to the top. At that point, when it's at the top, the velocity is 0, but then it goes faster and faster, faster all the way down until it hits the ground. So if we want to know that, then that's pretty simple. All we need to know is the velocity. If we have an acceleration and we start from rest, that's just equal to gt, right? Just like if it were not a free fall, but a horizontal type problem, our velocity would be acceleration times time. Those two equations are derived from the idea that acceleration is change in velocity over change in time, and g is equal to the change in the velocity over the change in time, right? That's how we're doing it. So we'll use this one. So your velocity is gt. So that's 9.8 meters per second squared. And we know it's 2.2 seconds. Okay, so that's essentially 10 times 2. It's about 20. It's a little bit off of 20, but it's pretty close to it. Let's see what it comes out to. 9.8 times 2.2. And it looks like at 21.56 meters, I'm actually going to go ahead and round that off to about 22 meters per second. Okay, one of the seconds, that cancels with that second, and you've got meters per second. Okay, so there's your final. So in other words, when it hits the ground, right before it hits the ground, it's moving at about 22 meters per second. But also when you throw it up, the initial speed is 22 meters per second.